Welcome to my new calculus channel. My name is John Gabriel, and in this video we're going to be talking about proposition 16 of book 1 of Euclid's Elements. So let's begin. Now that proposition says that for any triangle, when one of the sides is produced, the external angle is greater than each of the internal and opposite angles. And Euclid goes on to a proof which is, again, without the use of circles and a little hard to understand. So this is the diagram he constructs. Now the proof is very easy if we consider that we have this triangle that Euclid talks about, ABC, we're not going to use his construction. This is Euclid's construction, but it's actually unnecessary because, again, we're going to focus on the fact that an angle is defined as the measure of an arc length to a radius. So for any triangle, as you see here, this ABC, when one of the sides is produced, the external angle is greater than each of the internal opposite angles. Okay, so let's see the proof of that. So if we move this center, if the center coincides with C, then the blue arc, this blue arc, is greater than the red arc. So if we do this, as you'll see there, and this blue arc here is greater than this red arc. Okay, just this section, which corresponds to this little arc here. So this part of the blue arc and this red line, this red arc, are in proportion. But because the angle we're looking at, ACD, let's just bring this closer, the angle we're looking at is greater, it has the greater arc, so therefore the blue angle is greater than the red angle, okay? So to prove that the blue angle is greater than the green angle is easy, since the green and the red are supplement of the angles in a triangle, or supplementary of the angles in a triangle. Okay, so in other words, red plus green plus this angle are two right angles, but it just so happens that the blue angle plus this angle are also two right angles, which means that the green angle can only be less than the blue angle. And so we're done. Incidentally, it also proves that the blue angle is equal to the sum of the red and the green angle. It's as simple as that. So hope you've enjoyed this short presentation, and remember that you cannot have a measure of an angle without referring to the circle, and that most of the propositions in book 1 are better illustrated using circles rather than the long drawn-out arguments of Euclid. And that's all I have for this video. My name is John Gabriel, and this is the new Calculus channel. Till next time, goodbye.